Today, I'd like to share a real maintenance case that our team recently encountered involving a Rotork valve that had become completely stuck. This issue caused the valve to fail during operation, and it eventually led us to perform a full teardown, inspection, and repair. The problem turned out to be more serious than we initially expected, but fortunately, after proper troubleshooting and corrective actions, we were able to restore the actuator back to normal operation. In this video, I will walk you through the full story, from the first signs of failure, to the investigation steps, the root cause, and finally the successful repair. The incident started when the operations team contacted us because the valve would not respond to open or close commands. According to them, the valve remained in the same position regardless of the signal sent from the control system. There was no movement, no sound of actuation, and no indication that the valve was trying to operate. At first glance, this kind of symptom could originate either from the valve body itself, where internal mechanical components may be stuck, or from the actuator, where gearing or motor components may be jammed. To identify the cause, we decided to verify each part step by step. After arriving on site, we attempted to manually operate the valve, but it still wouldn't move. So we proceeded with isolation and mechanical disassembly. We removed the actuator from the valve body to check both sides separately. Once the actuator was detached, we tested the valve body by hand to confirm whether the valve disc or internal mechanism was stuck. Surprisingly, the valve body itself rotated smoothly without any abnormal resistance. That immediately told us the valve body was not the source of the problem. Next, we focused our attention on the actuator. After removing it from the valve, we tried to manually drive the actuator output shaft, but it was extremely stiff. There was a clear indication that something inside the actuator was binding. At that point, we knew the issue was coming from the actuator mechanism, so we transported the entire unit back to the workshop for a more detailed inspection. Once in the workshop, we began a full teardown of the actuator. We removed the covers, gears, motor, and all internal components. Right away, we noticed an abnormal amount of moisture inside the housing. Water had somehow entered the actuator, causing corrosion on several metal components. Many of the moving parts were dirty, and some of them showed signs of wear and looseness. The lack of lubrication was very obvious. Parts that were supposed to be greased were either completely dry or had only small traces of old grease remaining. The presence of water was the biggest concern. Moisture inside an actuator can cause rust, increased friction, electrical problems, and eventually complete failure of the mechanism. In our case, the water had caused enough corrosion and contamination that the moving parts could not operate freely. The gearbox was particularly affected, with some sections showing a combination of rust and hardened debris. This buildup restricted the motion of the gear assembly, which is why the actuator output shaft would not turn. To fix the problem, we carried out a thorough cleaning process. First, we removed all rust using appropriate tools and cleaning agents. We wiped every component clean and ensured there were no remaining traces of moisture. After cleaning, we inspected each part for damage. Fortunately, even though the actuator was very dirty and contaminated, none of the major components were broken. The wear and looseness we found were still within acceptable limits, and no gear teeth were damaged. Once everything was cleaned, we applied fresh lubrication to all required areas. We used high-quality grease recommended for this type of actuator to ensure smooth motion and long-term protection. Every moving part, including bearings, shafts, and gear interfaces, received a proper amount of lubricant. Then we reassembled the actuator carefully, making sure all components were aligned and tightened according to specifications. After reassembly, it was time to test the actuator. We connected it to a power supply and performed several open-close cycles. The results were excellent. The actuator operated smoothly, quietly, and without any hesitation. The output shaft rotated fully in both directions, and there were no more signs of binding. We repeated the test multiple times to ensure consistency, and each cycle was successful. At this point, we were confident that the actuator had been restored to proper working condition. From this case, we learned several important lessons. First, regular inspection and maintenance are essential for actuators, especially those installed in environments where water ingress is possible. Even a small amount of moisture can lead to corrosion over time and eventually cause mechanical failure. Second, proper lubrication is critical. Without grease, friction increases, components wear out faster, and the actuator can become stuck. And third, early symptoms should not be ignored. If a valve begins to operate more slowly or with abnormal noise, it could be an early sign of internal problems. In our situation, the actuator had clearly not been serviced for quite some time. The combination of water ingress, contamination, and lack of lubrication caused the internal components to deteriorate until the actuator could no longer function. Thankfully, we were able to resolve the issue before it caused bigger operational problems on the plant. After completing all the workshop checks, we returned the actuator to the field and installed it back onto the valve body. We performed alignment checks and ensured that the actuator was properly seated. Then, we carried out a full functional test together with operations. The valve responded immediately to open and close commands, and everything worked normally. With the actuator fully restored, the equipment was returned to service. This case highlights how important it is to maintain Rotork actuators and similar equipment in good condition. Proper sealing, correct lubrication, and periodic inspection can prevent many issues before they escalate. And when a failure does occur, a structured troubleshooting approach, isolating the problem, dismantling carefully, checking each component, and performing thorough cleaning, can make the repair process more effective. Thank you for watching, and I hope this breakdown of our maintenance experience gives you useful insights for your own work in the field. If you want more real maintenance cases like this, feel free to let me know.